Let's take a look at a couple of examples, and we'll kind of work these out as we go along. The best thing that you can do with these is start to get used to drawing a picture. I know with some of these you'll get used to doing them in your head, but you should still get used to drawing out a picture, because when we go through more complicated examples, your picture will make your life much easier if you're already used to making those for the easier problems. So the first thing that we'll do is this first one tells us we've got a z value. So we know when you see the z value or a z that you're looking at a bell curve or normal curve. Now, when you've got z values, we also know that 0 goes in the middle. Specifically on this one, they're asking about z of 0.25, which is a little bit bigger than 0. So I'm going to draw a little line here at 0.25 as my z value. Now they want me to find all the area to the left. So I'm going to shade that in. You want all this stuff. The problem is, if we've got z values, what we're going to want to use is the normal CDF. The problem with using that is I need a start and a stop point. What we see is a natural stop point of 0.25. Our graph ends at 0.25, but that's where my graph would end, is the 0.25 of my z value. The problem is, on the left-hand side, I don't really have a starting value because it goes on forever. And so I need to give a really, really large value, but I can't give something like an infinity. My calculator won't understand it. So I need to give it a really, really big number that's down here, meaning it's negative. So the idea is using something like negative infinity, but not negative infinity. So I'm going to use a really large negative number to kind of start off my graph to let it know I want to get to really, really small negative, or really, really large negative values down here. So what I'll use is a negative, and I want something really big, so I'm going to use a 10 to the 99th power. So what this basically does is provide 99 zeros after that 10. And the negative out in front, make sure that I'm using a really big negative number. So I'm going to use a negative 10 to the 99th whenever I would normally have used a negative infinity. Okay, so I'll fill that in as kind of my start value as my negative 10 to the 99th. And let's see what my calculator does for me. So to do the normal CDF, as a reminder, you'll do your second, then your vars or distribution key. You're going to arrow down to normal CDF. And remember, you'll start with your negative 10 to the 99th. Be careful that when you go in to type in the negative 10 to the 99th, that you use the negative key and not the minus key. They are not the same on the TI calculators. The negative key is towards the bottom of the calculator. It's not anywhere near the minus key, and it looks like a smaller negative sign that's a little bit higher up. And then you take your 10 and then raise it to the 99th power, and then you have your comma, and then you're stopping your graph at your other value, your 0.25. And what this does is it draws a normal curve. It figures out the area of probability as if your graph were going on forever, but stopped at 0.25. So our probability, or our area, either way that you want to say it, it's the same thing, is what this calculator gives us, which is the 0.5987. And that's our final answer. In problem 2, we want to find the area to the right of z equals negative 1.75. So I'd start just like the last one by drawing my curve. And again, it's a normal curve because we see the z that they gave us. Z's always go on a normal curve like this, where 0 is always in the middle when we have z's. And they're giving us a value of negative 1.75. So that means we're going to be down here below 0 somewhere at negative 1.75. But this time, they want us to find all the area to the right. So the question is, how are we going to do that? Well, because we've still got the same picture, we're still going to use a normal CDF. But to get this area or probability, remember we have to plug in a start value first. Well, we have to work on our graph from left to right. Well, we have a start value. We're starting our graph at negative 1.75. The problem we have is we technically don't have an official end for our graph because this area actually continues on to the right here forever. So it's going to be like our other one, but we're continuing towards the right, which is positive infinity. So to use a really large positive number, instead of using a negative 10 to the 99th like we did before, we want a really big positive number, we'll just use a positive 10 to the 99th. And that'll kind of be our placeholder instead of infinity. So we'll use a 10 to the 99th as a positive value and close that off, and we'll see what our calculator does for us. Notice, to get your normal CDF to work, you'll have to go in and hit your second button first, then your vars or distribution key. You'll arrow down until you get to normal CDF, and then the first thing you'll enter in after you press enter on normal CDF is your starting value, which was, according to our picture, our negative 1.75 as our Z value. We didn't have an official N value, so we used our 10 to the 99th, and you type it in just like that, 10 with an exponent of 99. Again, be careful, just like the last one, when you use your negative in front of the 1.75, that you use the negative key and not the minus sign, or you'll get an error. Press enter, and you'll get the following value as your probability or as your area here, which is 0.9599, and that's our probability or area here. That's our final answer, our 0.9599. And that's an area to the right. Let's take a look at number 3. On number 3, we're going to do the same idea. We're going to draw our normal curve because we've got Z's again. Again, as a reminder, 0 always goes in the middle. This time we're looking at wanting an area to the right of Z equals 2.33. Well, 2.33 is quite a bit bigger than 0, so we'd be down here somewhere. And then the area to the right means something like this. So it should be a pretty small value that we're looking for. So again, we've got our Z's, so we'll use a normal CDF again. Now, just like the last one, we have a start value. Reading this from left to right, the area does start here at positive 2.33 this time. It starts at a positive value. Comma, the problem, just like the last one, is it doesn't have an ending value. It's going to keep on going forever towards infinity. So if it's going towards a positive infinity, we're going to use a positive value. We use our 10 to the 99th we've been using, but we'll use the positive 10 to the 99th. So after our 2.33, our comma, and then we're going to keep on going forever, so we'll use a positive 10 to the 99th, and then we'll close off our normal CDF. And let's see what our calculator gives us. So notice what our calculator tells us when we do our second and then our vars and distribution key, and we arrow down to our normal CDF, and we give our starting value of 2.33 and our value that tells us we're not going to really end because we're going to use a really large value of 10 to the 99th, gives us a very small area probability, which is 0.0099. So that's our probability or area to the right. Continuing, if we look at problem 4, we actually want to find the area between two Z values. So what this means is we've got a first value, which is negative 0.51. Remember, what's in the middle is our 0 of our normal curve. So negative 0.51 is a little bit smaller than that. And then we also have 0.32, which is a little bit bigger than 0. And what we want to find is the area in between the two. So in between the two. What's interesting about this one is this is the first one we've actually gotten to do where we actually have a starting value on the left of 0.51 and an ending value of 0.32 on the right. So we can use our normal CDF normally. It'll be a normal CDF of our start value first, which is the negative 0.51, and then our ending value, comma, our ending value, which is 0.32 second. And we can use our calculator just like before, and let's see what we will get out. Notice the calculator gives us an area probability of 0.3205. And just writing out, like I've said when we did binomial probabilities, if you write out this normal CDF that you got from your calculator that you were trying to type in, that does help me quite a bit in assigning partial credit because I can tell whether or not you had the right idea. So our probability or area for this one, in between negative 0.51 is a z-value to the z-value of 0.32 is an area of 0.3205, or that's also can be seen as a probability. Now let's